In this video, I will discuss a question from JEE Main PYQ from the topic thermal physics. Let us consider a body of mass m and let it be supplied by a heat energy, say Q joules. Because of this, the temperature of this body will increase. So the change in the temperature, delta T, will be positive because heat is supplied. Final temperature will be more than the initial temperature. Now the question is, can we relate Q and this delta T? For example, if Q, I supply heat of say 3 joules and the temperature rises say 0.5 degrees Celsius. Now if I supply more heat, say for example 6 joules, then we can express this delta T to be more, but it turns out that the delta T is 1 degree Celsius. So if you supply heat of 1.5 joules, then delta T will be 0.25 degrees Celsius. These things can be checked by actually doing an experiment. So the conclusion from this is Q is proportional to delta T. If you double the Q, the amount of temperature rise will double. If you reduce Q by a factor of half, then the amount of temperature rise will also decrease by a factor of half. Here the mass of the object is fixed. Let's say the mass of the object was 2 kg. Now, suppose I double this mass, say 4 kg, and for the same temperature rise of 1 degree Celsius, the amount of heat required will be now 6 joules. For the same temperature rise, since I'm increasing, doubling the mass, more heat is required to heat this object by the same delta T. So similarly, if I reduce the mass to 1 kg and the temperature rise same 1 degree Celsius, then the amount of heat required will be less and it will be 1.5 joules. So we can also conclude that the heat required is proportional to the mass of the body. So these two we can combine and write as the heat required to heat the body is proportional to mass of the body and the amount of temperature rise. So this constant of proportionality is the specificity of the object. So the heat required to raise the temperature by delta T of mass m is mass into specificity into delta T. And the specificity of this substance we can understand like this. Suppose take 1 kg of this body and some heat should be supplied to it to increase the temperature by 1 degree Celsius. So this amount of heat is nothing but the specificity of the body. So in this relation, if you put this value of mass as 1 kg and the temperature is of 1 degree Celsius, we get Q equal to S. So this is one way of understanding the specific heat of the body. It is the amount of heat required to raise 1 kg of the material by a temperature of 1 degree Celsius. So this is a material property. Like if that is made of copper, copper will have one value. If you change it to aluminum, it will have another value. Hydrogen gas will have one value. So this is a material property. Now how to get the heat source to heat this body? We need a source of heat. One of the easiest way to get the heat source is to have an electric heater. Electric heater is nothing but a resistance and we have to pass a current to it by using a voltage source. So the power dissipated by this resistance is in SI units watts. So if you use this electric heater to heat this body for amount of time T, then the heat energy we get is power into time, this many joules. So to heat this body, we can use an electric heater. So with this understanding, we can solve the following question from JEE Main. Here is the question. You can read it. A water heater of power 2000 watts is used to heat water. The specific capacity of water is 4200 joule per kg per Kelvin. Efficiency of heater is 70%. Time required to heat 2 kg of water from 10 degrees Celsius to 60 degrees Celsius dash seconds. Assume that the specific capacity of water remains constant over the temperature range of the water. You can pause and run this question. Here is the solution. So the heat that is supplied to water, which is going to heating it, its mass is physically delta T. Mass of the water is 2 kg and specific capacity is 4200 SI units, and the temperature rises 10 to 60 degrees Celsius, so it's 50. So this heat is supplied by the heater, electrical heater. So Q is supplied by the heater. The rating of the heater is 2000 watts, so it's power into time. Another thing is, not all the heat energy is coming out of this heater is going in heating the water. Some of it might get lost to the surroundings, so only 70% of it is getting used to heat this water. So this is an efficiency factor eta. So this is the source of this heat. So these two should be equal. So if we equate these two, we get 2 into 2 into 50 is 100. So this will become 42,000. 42,000 I can write as 42K, where K is 1000. Power is 2000 watts, that is 2K. K is 1000. And time we have to find out the time the heater needs required to be on for heating this water. And efficiency factor is 70%. 70% nothing but 70 by 100, which is 0.7. So this is a simple calculation. Cancelling K and 2, we can make this 21. T into 7 by 10. So 7 will go 3 times. 21, 7 by time, 100, so 42,000, 3,002, 70%, so 7 by 10, so 210. So this is 30 seconds. So we have to check whether there's some mistake in the calculation. T is coming in 300 seconds. So mass is 2 kg, specific weight is 4200, delta T is 50, so 100. So this is actually 100 means 42 into it's 420K. So it's 210, so 300. So correct answer is 300 seconds. So heat required to raise the temperature of water is mass distributed delta T, and this heat is coming from the electric heater whose rating is P watts and will be used for the time T, which you have to find out. So P into T in the efficiency of the heater, because not all heat provided by the heater is going heating the water, some might get wasted. So this is the heat energy which is getting used to heat this water. So these two should be equal. So from this we get the time as 300 seconds.